Hey everybody, thanks for clicking on this video. Today we're going to be working with modeling cosine functions from graphs. Don't forget to hit that subscribe button so you can stay up to date on all the videos that we have coming out from the channel. Also, if you want to follow along, the links to the companion worksheet are in the description below. So let's get started. So what we have is we have this graph, and what we want to do is we want to model a cosine function. Now, I will post a link to the other video where we're going to be modeling just sine functions, but here we're just going to be doing cosine functions. And we always start with cosine functions because cosine functions are a little bit easier to model. Let's explain. When you're given a graph, the first thing you want to do is you want to identify the four key components. The first one being the amplitude. So looking at this graph goes down to the x-axis and then goes up to 9, 4. So where's the amplitude? Well, the amplitude is from the middle to the top and the middle to the bottom. Well, we're not quite sure where the middle is. So let's think about this. We're not quite sure about where that y value is, but we do know that that x value is 0. I'm going to leave that y value blank for the moment. And, well, I know that y value is 0. I'm not sure about that x value. The thing to understand about these types of graphs is that these are symmetrical, which means from here to here, from the middle to the bottom, and the middle and the bottom to the middle, and the middle back to the top are all the same length. So each of these three pieces are the same. And so that means that from here to here is 9. So that means from here to here is 3. And then from here to here is 3 more. So this is 6. Still don't know what the y value is. And then from here to here is 9. Now, just as it's symmetrical left to right, it's also symmetrical up and down. So the distance from here to here is also the same distance as here to here. So this should be the middle. So the bottom has a y value of 0 and the top has a y value of 4. So that means these should have y values of 2. So our amplitude is the distance between this y value of 4 and this y value of 2, which is 2. So that's the first component. The second component we need to identify is the period length. And that's how long it takes for it to complete a full cycle. So from here to here, nope, it's not a full cycle yet. From here to here, not quite. Here to here, still have a little more, because basically what we want to do is we want to hit a point that looks just like this. And that's going to be right here at 12, 2. Now again, I knew that was 12 because from here to here was 3, from here to here 3, from here to here 3, and from here to here was 3. And these 3 points all have the same y value. But after this point, it starts doing what it did already. So that's our period length. That's the shortest amount of distance that we need before it cycles. Now the phase shift. Now the thing to keep in mind is that this is a cosine graph. And so because it's a cosine graph, we want to know where is it at the top. Now normally it starts at the top on the y-axis, but it's not. It's over here. So that means the whole graph got moved over right there. So it got moved over 9 to the right. Now I'm just going to leave it as 9 as a positive number. And then finally, we need the vertical shift. And that's the value of the middle, which in this case is 2. So now that we've identified our 4 components, now we can write the equation very simply. Now I'm going to show you 2 different ways, because some people use angles in radians and some people use angles in degrees, and there's really only one minor difference. And it's totally up to you which one you want to use, or if your teacher expects you to use one or the other. So you start with the amplitude. That is 2 cosine. And so if you're in radians, you're going to take 2 pi divided by the period length, which is 12. And then multiply by x minus, now it's always minus, whatever the phase shift is. So in this case, the phase shift is 9, and then On the end, you add the vertical shift. Now, if you do this in degrees, then it's going to look like this. 2 cosine, and instead of 2 pi, you're going to use 360 divided by 12. Everything else will stay the same. And so there is our equation. And so this will look correct if you are in radian mode, and this will look correct if you are in degree mode. Very important that you're aware of what mode you're in when you're graphing these. All right, so let's move on to the next one. So here we've got this graph. It crosses at the origin, but that's not the bottom. The bottom is way down here, and the top is way up here. And so we still need our 4 components. So what is the amplitude? Well, notice that the middle is drawn for us, and that's at 8. And this low point is at -2. So the distance from 8 to -2 is 10. There's our amplitude. Now from here to here, from the low point to the high point, that goes from a value of 4 to a value of 24. If I draw that down, yep, there it is, 24. So from here to here is a length of 20. But the thing to keep in mind is that this isn't a full cycle. It went from the bottom to the top. To be a full cycle, it would have to go from the bottom to the top back to the bottom. Now, since it's a symmetrical wave, like I set up above in number 1, the period length is going to be twice that. The period length is going to be 40. And so for the phase shift, again, we look at cosine, and cosine starts up at the top. So we're looking at this point. Now, that point should be on the y-axis, but it's not. It got moved over this many spaces. It got moved over 24 to the right. And then finally, the vertical shift, and that is the middle. And so that value is 8. So we can now write our equation. And so in radians, it's going to be 10, that's our amplitude, cosine of 2 pi over 40 times the quantity x minus 24 plus 8. That's what our equation looks like in radians, so let's write it for degrees also. So it's 10 cosine, and instead of 2 pi, we put 360 over 40 times x minus 24 plus 8. And there's our equation. So let's look at the next one. Now for this one, quite a lot going on here. So let's look at the amplitude first. So if we look at our amplitude, it goes from -20 to 20, and it's centered at 0. So actually the amplitude is quite simple. It's 20. What about the period length? Something like this often gets students because they expect a label here and a label here and a label here. Well, this graph doesn't do that. Instead, from here to here is a length of 1. Now the issue is, how many full cycles have happened? Well, let's see. 1, 2, 3, 4. We have 4 full cycles. So how long is it for one cycle? Well, that's going to be 1/4. You just take 1 and divide by however many cycles there are. So that's our period length, 1/4. Now our phase shift is actually pretty easy here because our graph is starting on the y-axis at the top. So our phase shift is just 0. Likewise, so is our vertical shift. It's centered on the x-axis. So our vertical shift, that is also 0. So for this function, we have f of x, and that equals 20 cosine of 2 pi over 1/4 x. And we can clean that up a little bit. Let's, instead of dividing by 1/4, let's multiply by 4. So we get 8 pi x. Now that's for radians. In degrees, we would write this as cosine of, now it would be 360 divided by 1/4, but let's just go ahead and multiply by 4. So 360 times 4, well, that's just doubling twice. So 360 times 2 is 720, and then we double it again, and 1440x. So that's what our equation would be in degree mode. All right, so for this last one, here we've got these 2 points labeled. All right, so from here to here, we go from -8 to 2. And so that's a separation of 10. So that means our amplitude is the distance from the middle to the top and the middle to the bottom. So we have to take that 10 and split it in half. So our amplitude is 5. And then our period length. From here to here, we go from 70 to 130. And that's a distance of 40. But again, we went from the bottom to the top. We need to go back to the bottom again. So a full period length is not going to be 40. It's going to be 80. And then our phase shift. Now let's just use the point that's labeled. We could pick this point, but it's not labeled. We're just going to use this point and say that this is where it should have started, and it should be over here. It just got moved over, and it got moved over 130 units sideways. And then finally the vertical shift. That's just the middle. And so we need to figure out, well, what's the number that's halfway between -8 and 2? And the easy way to do that is just to find the average. That's what the average is the midpoint between two numbers. So if you add -8 and 2, you get -6. You divide by 2 and you get -3. And so that is our vertical shift. So our equation is going to be 5 cosine of 2 pi over our period length, which is 80, times x minus 130, minus 3. Notice the minus because it's beneath the x-axis. And then in degrees, it's going to be 5 cosine of 360 over 80 times x minus 130 minus 3. And that's what it would be in degrees. Thanks for watching. If you liked the video, please give it a thumbs up. Do you have suggestions or problems you want to see worked out? Type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.